Okay, let's get started. So, are there any questions? What's due today? Oh, go ahead.
I was going to ask if the assignment 2 is due today.
Yeah, what's due today?
Assignment 2.
Assignment 2. So, again, any questions? No questions? Okay. So this isn't up yet because the TAs aren't done making the test cases, but so this is just a preview of assignment 3. It should be relatively simple. So all it really is you're going to be inputting the user's going to be inputting 4 values, and then you just calculate some statistics on that data. So like average, the geometric mean, the standard deviation. So like if you wanted to know how spread out a piece of data is, that would be the standard deviation. This one is, and these last two are a little bit more complicated, but they're not that hard. It's just you have to think a little bit about it. So this one, print which pairs of the given integers are equivalent modulo 4. So basically, if you divide both integers by 4, even if they are different values, the remainder, they might be the same. So then you just print which of the pairs are equivalent there. And then this last one is doing the median. And you have to think a little bit about how you actually compute the median here, because you are advised not to do a brute force analysis here. And you can't use any for loops or sorting algorithms to sort the data. So you have to think a little bit about how do you find the middle 2 values, and then you can compute the median from that. So any questions about that? So this will be due in, I think, 2 weeks, so instead of 1 week. And then I'll put this up as soon as I get the test case. Oh, by the way, for assignment 3 and on, so instead of 25 test cases, what we're going to do is we're going to have 10 test cases, so 10 points for that, and then 15 points are allocated for something else. Usually it'll probably be like, are you putting good comments in? Do you have good code design? Is your program structured well? That sort of thing. So instead of everything on test cases, because we have a grader now, only 10 of them will be on test cases. Any questions on assignment 3? Or anything else? Okay, so last time we were talking more about if-else. So this construct to allow us to conditionally execute code. So if some condition's true, then only then do I want to execute this code. If not, then I don't want to execute that code. And then we started talking about if-else chains, which is if it satisfies a condition, do this code. Otherwise, if it satisfies a different condition, do this code. Otherwise, do this code, etc., all the way down, as many conditions as we want. So it's an if-else chain. And then sometimes we have a trailing else here to catch anything that didn't hit any of the conditions before that. So if the input age here is not at least 21 or at least 13 or at least 2, then that will fall into the case of the last else block here. Yeah, you can have nested if statements, so anything can go inside an if block or an else block for that matter. So it's just, you can put anything inside there. Yeah. Yeah, so if you have nested if statements like this, note that this else corresponds to this if, but what is a way that we can avoid worrying about that kind of issue? Yeah, put curly brackets in. So my recommendation, always put curly brackets in if you have if-else anywhere in your program. And then we looked at an example of a menu where we presented a menu to the user, and then we got character input from the user. And then we looked and said, is the user's input equal to option A, for example? and then we then want to execute the code corresponding to that option. Otherwise, else if their input matches the second option, which is B, then we do some other code. And then if it matches C, we do some extra code. Otherwise, then we might have some invalid input code to handle. Maybe we would want to ask the user, hey, input this input again until you get something that corresponds to the menu. Any questions about that sort of thing? Okay, so let's get a little bit more complex with our conditions. So let's just say that, for example, I have a program that computes some statistics on your exam scores, for example. And I want to input all of your exam scores into my program. So let's just say that there's no extra credit on the test. What is the range of valid scores that for an exam score to be if there's no extra credit? It's 0 to 100, right? So if I enter a negative number, unless I'm really mean, that probably isn't a good a valid exam score. And since there's no extra credit, 100 should be the maximum. You shouldn't be able to get any more. But the way we have it now, we would have to do an if check to see if it's at least 0. And then inside there, we have to do another if check to see if it's at most 100. Well, that seems kind of annoying, right? That we would have to do that. So wouldn't it be nice to have both of those conditions be in the same if statement, okay? So inside the same pair of parentheses, we put both of the conditions that have to both be satisfied. And so that's an example of a logical operator. So a logical operator, all it is one of these three operators. The first one is that example where I want both of the conditions to be true simultaneously. I want the score to be at least 0 and at most 100. So let's just see an example of doing that. So let's just say that we see out enter an exam score. Let's just do 1 to make it easy. And then we have let's just say it's an integer to make it easy. And then we see in from the user. Then from what we know so far, if we want to check that it's between 0 and 100, we would have to do something like this. If it's at least 0, then I'll need to do the other check to check that it's at most 100. And you could definitely do this. There's nothing wrong with this, but it's less maintainable than if you tried to put both of them together simultaneously. So the better idea is to do this instead. So to put the first condition right here, and then we put this logical operator corresponding to and. I want both of the conditions to be true. So then if I put and here, which is double ampersand, and then I put the other condition next to it, then we get exactly what we want. So here it's saying we put in the exam score. If it's at least 0 and at most 100, then maybe we can say see out valid as an example. And then otherwise, if one of the conditions happened to not be true, then it must be an invalid score. So then we can probably say see out invalid as an example. So let's run this. So let's G++ our program, and then enter an exam score. So if I enter like 67, that should be valid. If I enter 101, that should be invalid. And if I enter -1, that's also invalid. So it does actually work here. So it's really checking both conditions if both of them are actually true. Okay? But maybe in some circumstances, we want either one of the conditions to be true. We don't really care if both of them are true. At least one of them is true, is all that we need. So what would be an example of this? Yeah.
Lab 1 that we did, or was that lab 1 or lab 2? I don't know. Lab 2, the one we did yesterday. There is an example. You have to make sure you have to replace one of the midterms with final exam grade if it's less than the final exam grade.
Mm-hmm.
But you also want to make sure that the midterm you're replacing is less than the other midterm, so you can do them both at once.
Oh, so that's a great example. So remember lab 2, unless you haven't done lab 2 yet. But think of lab 2, where the part of the code where you have to replace the final exam percentage to the midterm percentage if the final exam percentage is bigger than the midterm percentages. So the idea there, so I won't do it because it's a little complicated and you're going to be doing it anyway. But if you look at whether the final exam score is bigger than either one of them, then what you can do is, if it's bigger than either one of them, you can infer, I now have to replace one of the midterm scores. So if the final exam score is bigger than the midterm score as a percentage, or is bigger than the other one, then I must be replacing one of them. If both of them are not true, which means that the final exam percentage is less than both of the midterm ones, am I going to be replacing anything? No. So in fact, that would be an example of an OR logical operator. So either the final exam score is bigger than the midterm one, or it's bigger than midterm 2, then I can infer, yeah, I'm going to be doing some replacing here. So an example of an AND would be, I want both of the conditions to be true, and OR would be either one could be true or both of them could be true. And the NOT operator just means whatever the condition was before, invert it. So if the condition happened to be true right now, inverting it turns it to be false. If it was false before, it's now true. So if we look at this, I have to put an additional set of parentheses in if I want to put a not here. So what does this say? So it says, if it is not the case that the exam score is between 0 and 100, what should I put instead here? It is invalid. Good. And then, of course, the other case is valid. So sometimes it makes sense to think to use not. Sometimes it makes sense to not use it. It just depends on the circumstance here. But think about this. Could I use and not, could I use or and not to simulate and again? So with the condition we had before, which was this and this, could I, let's just say I hate the and operator, but I love the or and the not operator. Could I convert this to just using ors and nots? Yeah, how would I do it? Yeah.
You place and with or
Mm-hmm.
and add before the
Okay, so let's think about this. So the suggestion here was convert the and to or operator and then put a giant not on the front. So let's see. Suppose we do enter an valid score. So let's just say 67 as an example. So let's look at this. Is exam score at least 0? Is 67 at least 0? Yeah. Do I need to then check this condition then? No. As long as one of them is true, then we can say the entire part corresponding to that is also true. Well, what about this not on the front? So what does that convert it from being from true to false? So that's not exactly what we want, but we're actually kind of close. What else should I change about this? Yeah. Yeah, so that's one suggestion, which is convert these greater than equals to be less than, and the less than equal to be greater than. Strict less than, strict greater than. So that's one way that I could do this also. Flip the signs around. And so this will definitely be okay. So let's look at 67 again. Does it satisfy either of these conditions? No, it's not less than 0 or bigger than 0. Bigger than 100. And so this inner part is false, but what does this not on the front make it? True. So in fact, if you flip the conditions on each of the parts in here, then you can simulate and with or and not. Could I simulate or with and not? Yeah, it's the exact same principle. I just I put a giant not on the front. I changed the or, in this case, back to an and, flip the conditions around. And in this case, I can remove the not here. And then we're back to the condition we had before. So you can actually simulate one with the other and not. Any questions on using this? Yeah.
Could you also bring the for greater than equal and less than equal, so not greater than equal?
Great question. So the question was, could we put the not instead around each of the conditions themselves? And the answer is yes. So let's think of that for a second. So let's go back to putting the giant not around the whole thing and change this back to an or. So we know right now that this is not a good idea. But what if this condition was much more complicated than just a simple greater than equal? What if it had like a whole bunch of stuff on the inside? Do you think I want to change each one of them? What could we do instead to do the opposite of this condition? Put a not around it. So if it's not the case that an exam score is greater than or equal to 0, and then we can do the same thing over here. So in fact, it doesn't matter what the condition is here. If we just put a giant not on the front of it, then we're okay, as well as over here. And then after that, we can do a giant not on the whole thing, and then we can do the exact same condition. But is this fun to write? No. So it's just more of a curiosity than practical. Sometimes it actually is useful, but most of the time it isn't. The key here is being able to use and, ors, and nots. Any questions about how to use them? Yeah.
For the greater than or equal to, you can't just put like normally how you put in math. Like you can't put
Yeah. We're actually going to get right back to that. So the question was, I couldn't do something like this. I wish we could, but we can't in C++. And actually, we can see that it won't actually work. Yeah, it says it actually does something completely different than what it looks like it's doing here. In Python, a different programming language, this is valid, but in C++ it isn't. Yeah.
Can you do it with like 3 inputs? So what if you want to compare 3 different values all in one if statement? So like you want 3 things to be true, all in one.
Yeah. So the question is, can I do 3 different conditions in the same if statement? And of course. So I can do exam score, let's just say, times 100 is less than 5,000, as an example. So I can have as many conditions as I want. I can chain ands, I can chain ors, I can put parentheses around everything. I can do whatever I want here. So I can put as many conditions as I want here. But it's just, it might be a little hard to read if you put too many here, but you can certainly do it. But any questions on just using them? Using ands, ors, and nots. Okay, so let's look at this. So these are just the 3 that we talked about. Here are just some examples of using them. So you can have x greater than y and y greater than z. So this one would be true because 12 is greater than 5, and 5 is greater than -4. This one is false because 12 is greater than 5. That's okay. But -4 is not bigger than 5. Oops. -4 is not bigger than 5. And so true for the first one, false for the second one, and says you have to have both of them be true. But since one of them is false, the entire thing is false. For this one over here, x less than or equal to z, is 12 less than or equal to -4? No. So this one's false. Do I need to check this second one because this first one's false?
Yes.
Yeah, because it's an or here. Is y equal to z? No. 5 is not equal to -4 as far as I know. X less than or equal to z, still false. Y not equal to z. Is y not equal to z? Yeah, 5 is not equal to -4 as far as I know. And so as long as one of them is true, then the entire thing is true because it's an or. Is it not the case that x is bigger than z, at least z? So is 12 bigger than z? Yeah, so it's true, but the not on the front says flip it around, so it's false. So that's why it says false here. Okay, so this is just an example of you don't have to put just a less than, not equal, whatever as the condition. You can put something that evaluates to a bool. So you can have a bool variable or a flag or whatever right here, which is initially false, and then we can use that in one of the conditions. You don't have to just put a comparison here. Yeah. So this is kind of interesting, and it's lying a little bit. But it's good enough for us, so it's fine. Consider the AND operator. Do both of them have to be true for the whole thing to be true? Yeah. So if one of them is false, the first one it checks is false, does it need to check the other one? No. So that's an example of what is called short circuit evaluation. So if it finds that it only really needs to check one of the conditions, it won't check the other. So that is definitely true. For or, if one of them is true, does it need to check the other one? For or, no, because regardless of the other value, the whole thing's going to be true because one of them is true. So these two are always true, but it's a little misleading. So what order, so let's look at the example we did before. So let's just make it easy and look at the example we have here. So the example we had was, it's at least 0 and at most 100. Question for you, which one does it check first? So this is actually something that is a highly debated topic in the C++ community. You actually don't know for certain which one will be evaluated first. Usually it's left to right, but you can't actually guarantee which one it is. The standard for C++ actually says that the compiler can actually make a decision as to which one to evaluate first. It's totally free to say, I'm going to check at most 100 first, then I'm going to check at least 0 first. But if it finds whatever it checks first to be, in this case, false, then it definitely won't execute the other one. But just understand that it doesn't guarantee that the left one will be executed first, then the right one. So you could, in principle, have something like this. So you could have some code right here. You can have a function like low work right here, and then a different function, lots of work right here. So in this case, if we have some code that doesn't take a lot of time to execute, and a function that does take a long time to execute, we may think, okay, it's going to execute the left one first, and if we execute only a little bit of work and find that it's false, I don't have to do a lot of work to do the second condition. But some programmers, C++ programmers, have been burned by this because the compiler sometimes can choose the lot of work one first. So we do a lot of work to find out, okay, now it's false, and then I do the other condition, find out it's false, and then we just wasted a lot of work. So just understand that the compiler can do either of the conditions first. That's all you really need to know. But short circuit evaluation is definitely true. In the case of AND, if one of them, the first one it checks is false, the other one will definitely not be executed. And then similar thing for OR. Any questions on what short circuit evaluation is or its implication? Yeah.
So what you mentioned just now is just a matter of speed of the program.
Yeah, so the question is, the example that I did right here where you have a function that does a lot of work and one that does a little bit of work. Yeah, so the only thing that matters here is how long it takes. So the correctness is still guaranteed because of how the AND operator works, but it's just that you don't know necessarily which one will be executed, and so it may take a much longer time than you expect to do this if statement here. Yeah, but the correctness is guaranteed.
Couldn't you ensure that it does the low work one first by just doing the nested if statement?
Yeah, so great question. So what the suggestion is, what if we did the nested if statement like this? Oops, I need to fix some stuff. And then let's just say we have something like this. Let's just make it really easy and not put a whole bunch of code here. And so you may think, well, okay, this is doing the exact same thing, and this is actually guaranteed to execute low work first, then lots of work next. Yeah, so this is a workaround. So depending on the circumstance, you may want to do this instead. In fact, in my own research, where I need every single clock cycle of the computer to be doing lots of work efficiently, I do this sometimes, where instead of having a something and something else, I break it up into nested statements because I can guarantee it's faster that way. So it just really depends on what you're actually doing. In this class, maybe we'll have one assignment that requires a lot of computation, but the vast majority of the time in this class, try to make the code more readable like this, to have if this and this instead of breaking it up. But there may be one assignment where we will consider the other option. But any questions overall on short circuit evaluation or logical operators, that sort of thing? Yeah.
How does it like compare values of functions against true and false? Like,
We haven't gotten to functions, but we can have functions return bool values, and so that would be an example of that. This is not valid C++, by the way, so don't try this. But it's just that if we had something that evaluates to a bool that only takes a little bit of time and a different one which takes a lot of time, then that would be a case like this. Other questions? I may talk about how I actually use this in my research sometime later in the class, but yeah, just try to make your code more readable is all I'm saying. But you may think, okay, if I could have a set of conditions where instead of it just being and this, and this, and this, and this, I could just say this and this, or this and this. Okay, so maybe we could combine different logical operators together. So you may think, okay, if I have like 2 less than 3 or 5 greater than 6 and 7 greater than 8, depending on which one of those operators is executed first, it may depend on, it may give a different value, different result. So the way that it works is, if the program finds a not somewhere in the condition here, it executes the not first. Okay, so not has highest precedence, meaning that anything corresponding to a not, that is executed first. And then once the nots are taken care of, then we look at any instances of and in the expression. And then once we take care of those, we look at finally or, which is the lowest precedence. So look at this example right here. Are there any nots in this expression? No. So great, we just took care of that. We're all set. Then we look, okay, are there any ands in this expression? Yeah. So then what we do is we look at the two arguments corresponding to the and here and ignore all others temporarily. So in this example, we're going to look at this and this. So 5 greater than 6 and 7 greater than 8. So is 5 greater than 6? No. So do I need to check 7 greater than 8? No. Why? Because this and this type of thing is called short circuit evaluation. Good. So yeah, so the result of this and therefore is false. Good. So we have 2 less than 3 or false. So basically what happens is this part gets substituted with false right now. So are there any other ands in the expression? No. So now we're back to the lowest precedence. So then we got to look at the condition 2 less than 3 or false. So is 2 less than 3? Yeah. So do I need to check the other condition? No. Well, it doesn't matter what the other one is. So 2 less than 3 is true. So the entire result of the entire thing is true. So then the result of this computation is true. Okay, any questions on how yeah?
Can you force precedence using brackets?
Yes, you can force precedence using brackets, absolutely. So what happens actually, so this example is a little misleading so everything in this class is misleading apparently. So what we can do is we can enforce precedence by doing putting more parentheses in. So what actually happens is it goes to the deepest level first and then looks at the 3 precedences and then peels back a layer, I guess that's the opposite, right? It goes to the core of the onion, so to speak, and then it moves out layer by layer. So here what happens is this expression right here is going to be executed first. So what does this expression evaluate to? True, because 2 less than 3 and then or something. So the result here is true. Not in the right font, but so yeah, this thing results to true. What is the result of this now? False. So in fact, by enforcing precedence on different things, by putting parentheses in, we can change the value. So so be very careful in how you structure these because the value can actually change depending on where you put parentheses. But it looks at the lowest parentheses level, so to speak, first. The reason why we didn't have to worry about that here was that the level at each one of these conditions was always 1. There was nothing deeper than any of the conditions here, so it's a little misleading. But any questions on this example? So think of PEMDAS for doing computation with numbers. Same thing here, but it's P not A for and then O for or. So P now. Yeah. So yeah. Don't forget P now. Okay. So it always does parentheses first. But any questions otherwise? Okay, so let's do that. So, but instead of just working with logical operators, we have some arithmetic ones too. So like if we have x plus y in the condition, and then we have a less than, and then ands and ors, what is going to be executed first? So what happens is the arithmetic is done first. So any arithmetic, so in this example right here, where's the arithmetic? The 2 plus 7. So that results to be, let's actually work through this. So 2 plus 7, that is going to be substituted with 9. Are there any other arithmetic operators here? No, so we're all set there. Are there any relational operators here? There's 2. So the 8 less than 9 one will be true, and then 5 is equal to 6 turns to be false. True or false is true. So that's why it says true. So is this code fun to read? No. What could you do to make it easier to read? Put parentheses around it. Yeah. So you can actually enforce the same precedences like this. So put parentheses around all the arithmetic ones, then the relational ones, then the logical ones. And so you can enforce precedence like this. Actually, you're not enforcing precedence, but you're making it clearer what the precedence actually is. So don't write code like this the original way. This way is better, with putting parentheses around to make it clearer to understand. Okay, so let's do actual code examples. So this is actually one that we pretty much have seen already. If grade is at least 0 and is at most 100, print valid grade. You can test if a value lies outside the range. There's actually a bug in this code. So this is from the publisher, not me. What is the bug with the second example? What if someone gets 100? It prints invalid. So just by flipping the condition, this is not correct. What is an easy way to, instead of putting knots, a whole bunch of knots in here, what is an easy way to fix this? Delete the equal sign, yeah. So the exact opposite of less than equal is strict greater than, okay? If we had no equals on this one, what would we do with this one? Put equals in. So the opposite of strict includes the equality for the other direction. So just be careful about that. If you can't just flip the condition with the equal sign and expect it to do something different, the opposite. And you can't use this, unfortunately. With more civilized languages like Python, you'd be able to. Okay. Yeah. So when would this actually be useful? So if you look at this example with the 0 and 100, that could be for input validation. So that's the usual circumstance of when you would want to use this sort of thing. So don't actually do this if you ever work for a website that handles passwords. But what is a common password requirement for a website? Don't actually do this, but what is an example? The number of characters between, say, 8 and 32 characters. So how would you handle the validation there? So what you would do is you would take the string as input, namely the password, and then you just check, is the length of the string at least 8 and at most 32? If it lies outside of that range, is it a valid password? Well, it should be, but some websites still enforce that. But according to them, that is not a valid password. So that's an example of when you would want to use input validation to check if something is true and something else is true. An example of a validation would be, so let's just say they did input their password to log in. What would be a check to see if they actually entered the right password? Well, to check, look up in the database at their username. If the inputted password matches the one that's stored in the database, should you let them in? Yeah, if it doesn't match, should you let them in? So then what you can say is the password of the right length, and did they enter the right password? And then you can actually put parentheses around the password checking part to enforce it to say, do the password check first and then look up in the database. Okay? So, yeah, it's commonly used with input validation. So the range is the most common case. Reasonableness, I'm not sure what that actually what that actually means. Valid menu choice, that's an example we saw last time. Did they enter a valid option on our menu? And this one's interesting too. So if you're going to be doing integer division or even floating point division, you may want to check if the bottom number is not 0. So if it's not 0, then it's okay to do the division by that number. If it is 0, is it okay? Probably not. So that would be a case of when you want to make sure that you don't have 0 as a divisor. So anything that could really make the program go wrong or crash or that sort of thing, you want to validate the input first. Okay, any questions on, this? Yeah.
Are we talking about sanitizing user inputs? Like this, they would use logic like this to sanitize
Yeah.
user inputs?
That's commonly the case. So like if the input is in the right range or is a valid menu choice, then that would be an example of that. So what you could do, say for a menu, when would you want to use and for this? Or? So this is, we'll get back to this sort of thing, but let's just say that we have a menu that has a single option, quit the program. And let's just say we have a character and then we cin that character. And let's just say that the user can actually enter lowercase a or capital case A here, even though the program says lowercase a. So what could we do here? Well, we could say if C equals lowercase a, do some code. And then somewhere down here we can say if it's capital case A, then we do the exact same code. But what's a better way? Use or. So then we can instead say or C equals capital A. And then if they have, so they're intending on using this option, even though they didn't enter exactly what was printed on the menu. So we're actually making the program more user-friendly here because they can enter other things, even though they're not exactly the same, we can consider them to be the same. So lowercase a, capital case A, we'll consider them to be the same thing. Okay, so that would be an example of making the program more, I guess that's what the reasonableness is part of, right? Making the program more reasonable for the user to use. But any questions on this? Because we're going to switch gears a little bit. Okay, so we talked about scope of variables before. So ignore what it says on the slide right now. What was the scope of a variable as we saw it before? Right, so it's wherever we can use a variable. So if we declare a variable somewhere, ignore this. If we declare a variable somewhere, where can we use that variable? Anywhere from there down, right? We couldn't use it before because we can't use a variable before it's declared. So that's what the scope of a variable was. Where can we use that variable? So this is what we have known it so far. But since we have if-else statements now, there's actually a different level of scope now. So consider this program. So let's do this. So let's just say if they entered the right input, let's create a variable called x and set it to 5, and then we can do some code later to it. What about this? And maybe we modify x in here somewhere, it doesn't matter. What do you think would happen if I try to run this? So how many of you think it's going to compile? Got a few. How many think it's not going to compile? A few more, and some of you are still asleep. So let's just check. Is it going to compile? And in fact, it doesn't compile. Even though we're using the variable below where it's declared. Kind of interesting. So this is a different kind of scope because we have these curly braces in here, namely the if statement, but we have the curly braces here. So what's actually going on? So what is happening here is that the variables that are declared inside the if statement block here are have something called local or block scope. Okay, so what happens here is that if you're declared inside of a certain scope, whether it's inside main or inside an if statement or anything else really, you can only use that inside the same scope. Okay? So let's think of this though. So this clearly is wrong, right? I can't use x down here because it's outside of the local scope right here. But what about this? So what about this? So if we have if c equals lowercase a, maybe we want to do something specific. What if we did that instead? Would this be okay? How many think it's okay? How many think it's not okay? So let's figure out. And it actually works. So even though this is different scope, so what happens is that this is nesting scope. So what is the scope of x right here? The scope of x is from where it's declared until it reaches the corresponding closing curly brace. So the opening curly brace for x is right here, so corresponding to this if statement, and the corresponding closing one is down here. Anything that happens inside the middle, you can still use x. Okay? So you can think of this as x is created right here, and it's destroyed right here at the closing curly brace. Here's something really, really interesting and kind of mind-boggling. Actually, let's comment this out for a second. So we can obviously do this, create a variable like this. Can I do this? No, why not? Because I'm redeclaring the variable x. And in fact, if we try to compile, it'll give us an error. You're redefining x here. Now think of this. And let's get rid of this to make it easier to read. Will this compile, even though I'm redeclaring it right here?
That's a conditional.
How many of you think yes? How many think no? Mind-boggling at 9:20 a.m., right? Let's compile, and it works. So can anyone tell me why?
Because it's conditionally redefined. It's not, it's basically asking a question. So if the c equals the lowercase a or the uppercase a, then make x 5. So it's still asking the entire question instead of just redefining.
What about this? This if condition will always be executed.
That should be fine then.
Yeah, and in fact it is. So there's actually something else going on. Yeah.
A question though, will it change back to 10 at the end of the if statement?
Great question. So what do you think will be outputted here? It'll actually print 5. So if we, it'll print 5. So this x right here really is talking to this x. But what about this one? So what happens here is that this if statement is a different scope. Okay? Even though it's nested, it's a different scope. So this x right here and this x inside the if statement are two different variables. Yeah.
So if we pulled the C out outside of the curly bracket, would it then print 10?
Yep. Actually, let's find out. I'm pretty sure it'll print 10, but we'll see. Yeah. Because this x right here is a brand new variable. It's not the same x as before, even though it's named the same thing. So this is legal to do in C++. Is it a good idea? No. So always use a different variable name. Yeah.
If you got rid of the int, wouldn't that just redefine the first x?
Ah, great question. What if I did this? Yeah, so this will do effectively the same thing, except it'll print 2 5s. Because now there's only one x declared, so this one must refer to the one on the outside of the if statement. Kind of mind-boggling, isn't it? So I'll leave you with that, and I'll see you on Friday.